Hi, it's Saturday, June 13th, 2020. My name is Noah Seeley, and welcome to my channel. So today we're going to be continuing our series of the content relating to reinforcement learning within the realm of machine learning. On Wednesday, we started an article by Chris Nicholson that introduced us to a few basic concepts of reinforcement learning. We only covered about half of it though, so I thought today's video could act as kind of a part 2 to Wednesday's video, and we could finish walking through this introductory article. Once we finish that, I think we'll be in a really good spot to start talking about reinforcement learning. So next week, I'll hopefully have some papers to discuss with you guys. So to just quickly recap the part 1 video, reinforcement learning is based loosely off the ideas from reinforcement behavior psychology, saying that the frequency of an individual's actions are proportional to the reward or consequence of that action. So in reinforcement learning, we apply this concept to various algorithms with an agent using actions in an environment, learning to optimize the rewards given by the environment. We reviewed all of this and more in the part 1 video, so I advise you to check that out if you haven't already, and I'll link that video in the description below. So now that we've summarized part 1, let's jump into the rest of the article. So this second half of the article basically has 4 sections on different aspects of reinforcement learning, and we'll just make our way through each of those. So the first section starts by introducing one of the main problems faced by data scientists in reinforcement learning, what your agent should pay attention to. Nicholson talks about how the agent is basically a blind person walking through an environment randomly and will learn through the narrow scope of input that the developers present to it. He introduces this selection of input as domain selection. A reason why video games are such a good testing area for these agents, as mentioned in part 1, is because they offer a pretty static environment for the agent, thus making domain selection much more trivial. Domain selection is much more difficult for projects such as self-driving cars. What input would you give a car that would have to optimize safety, navigation, and efficiency all at the same time? Perhaps a GPS, tire traction, or even some sort of input from passengers. The answers to these questions could change the effectiveness of a model significantly and are important to be aware of as we continue to discuss reinforcement learning. The next section discusses how at each state the agent must have some sort of ranking as to what possible actions they can make in order to optimize their decision making at each state. This is where state action pairs becomes more relevant. It discusses how the policy can be derived from figuring out the probability of an action occurring at a given state. The agent can then rely on sampling from this probability in order to figure out which move to make next. Another important aspect of reinforcement learning Nicholson discusses here that can be made relevant from this decision making is the difference between exploitation and exploration in an agent. An agent that exploits will try to abuse a local reward again and again, maximizing their score, but not really leaving that specific area. An explorative agent will focus on exploring the environment with a more global reward in mind. They won't necessarily get a very high score, but will hopefully see the whole environment. The concepts discussed in this section are pretty key to setting up an effective agent model, and as we go on, we'll see the different methods researchers have used thus far to try and create a good agent. The next section simply discusses the potential of reinforcement learning. Nicholson explains that because of the iterative type of training the agents go through, they'll be able to learn much more than humans will ever be able to in a relatively fast amount of time. One reason for this is because they continuously repeat very tedious steps of a process over and over again, without any risk of injury, fatigue, or anything else that would hold a human back from achieving perfection in a learned process. This section alone shows the power reinforcement learning may have as it continues to advance and spill into the realm of robotics. Robots trained this way will be able to achieve far more than humans ever have, and we've even already seen some evidence of this from the bot trained to beat the best Go player in the world, known as AlphaGo. The final section discusses the use of neural networks in reinforcement learning. Nicholson talks about how neural networks can be used to substitute policy or state action tables for very large real-world problems. The neural network can be trained in order to classify which action is thought to be valuable given a state. So this can save a whole lot of time and space for the reinforcement learning model, as it will no longer have to store a large exhaustive table mapping states and actions for the agent for each possible state and action. So this neural network can be thought of kind of as the brain of the agent. The article shows that we can use a convolutional neural network to visualize the state of the environment and then process which action would be most likely to yield the best reward given that state. Backpropagation can basically be used for the neural network to learn which actions give the best score given the state. Thus, the agent will be able to learn to maximize their score given the environment. environment. I think this section alone offers just how complex reinforcement learning is at this point in time, which makes me think that it must be an extremely powerful tool in AI. I think it's also important to note that we saw how many topics in machine learning are being combined in order to implement a very powerful model. We see how the convolutional neural network is used to further optimize the performance and efficiency of this reinforcement learning model. I think this also ties all of the concepts that we've been looking at on this channel thus far together very well. So yeah, that concludes my little video series of an introduction to reinforcement learning based on this article by Chris Nicholson. I hope you've learned a lot about reinforcement learning and that you're as excited as I am to come back and review some more reinforcement learning work, as that's where I want to kind of move with the channel's machine learning stuff. So yeah, like I said, Nicholson covers a lot more in his article and includes a lot of great resources for learning about reinforcement learning. So as always, I've linked all resources that I've used in the description below for you guys to check out yourselves. If you feel that I've missed anything today or got anything wrong, please let me know in the comment section below. That's it for today. Thanks for watching. See you tomorrow.